Several factors could contribute to electrical malfunctions following new wiring or circuit breaker panel installation. Firstly, reversed wiring could be a culprit. If the electrician inadvertently connected the 220 volts hot wire to the 110 volts neutral wire, a voltage surge could damage appliances. Secondly, overcurrent is another potential cause. If the circuit breaker panel wasn't properly sized or the wiring was insufficient, excessive current could flow, leading to overheating and appliance failure. Thirdly, a short circuit might be the issue. This occurs when a live wire contacts a neutral wire or ground, creating a low resistance path for excessive current, again causing overheating and damage. Now about testing with an ammeter before connecting wires. While it can help identify potential problems, it's not a foolproof solution. Firstly, it doesn't detect reversed wiring. An ammeter measures current flow but can't determine if the hot and neutral wires are correctly connected. Secondly, it doesn't detect overcurrent on its own. An ammeter measures current, but it doesn't inherently indicate if the current exceeds safe levels for the circuit or appliances. Thirdly, it doesn't detect short circuits directly. An ammeter measures current flow but can't definitively determine if a short circuit exists without further investigation. To prevent these issues, consider these measures. Firstly, prioritize hiring a qualified electrician. Even in areas without licensing, seek a reputable and experienced professional. Secondly, carefully inspect the wiring before connecting any appliances. Look for signs of damage or incorrect connections. Thirdly, employ a voltage tester to confirm that the voltage supplied matches the appliance's requirements. Fourthly, install surge protectors. They can mitigate voltage spikes and protect appliances. Fifthly, implement regular maintenance. Inspect and maintain electrical components to prevent minor issues from escalating. To elaborate on reversed wiring, consider the standard wiring in many residences. Typically, you have 110 volt circuits for most lights and outlets and 220 volt circuits for high power appliances like stoves and dryers. The 110 volts is usually supplied by a single hot wire, a neutral wire, and a ground wire. The hot wire carries the current, the neutral wire returns the current, and the ground wire provides a safety path in case of a fault. If the hot and neutral wires are reversed, several things can happen. Firstly, appliances might not work correctly. Some appliances are sensitive to polarity, and if the hot and neutral wires are reversed, they might not function as intended or at all. Secondly, there's an increased risk of electric shock. With reversed polarity, the appliance's metal parts could become energized, posing a shock hazard. Thirdly, there's a potential for damage to appliances. Some appliances are designed with the expectation that the hot and neutral wires are connected correctly, and reverse polarity can damage their internal components. Overcurrent can stem from various factors. Firstly, overloading a circuit occurs when you plug too many devices into a single circuit, drawing more current than the circuit is designed to handle. Secondly, short circuits, as mentioned earlier, create a path of very low resistance, causing a large amount of current to flow. Thirdly, ground faults occur when a hot wire comes into contact with a grounded surface such as a metal enclosure or a ground wire, also causing a large current flow. Undersized wiring can also contribute to overcurrent. If the wiring is too thin for the amount of current it needs to carry, it can overheat and potentially cause a fire. Circuit breakers and fuses are designed to protect against overcurrent. They trip or blow when the current exceeds a safe level, interrupting the flow of electricity and preventing damage to the wiring and appliances. However, if the circuit breaker is faulty or the wrong size, it might not trip when it should, leading to overcurrent damage. Ammeters, while not a complete solution, are valuable tools. They measure the current flowing through a circuit. There are two main types: clamp-on ammeters and inline ammeters. Clamp-on ammeters measure current without having to disconnect the circuit, while inline ammeters require you to break the circuit and insert the meter in series. Ammeters are useful for diagnosing electrical problems, such as identifying overloaded circuits or detecting excessive current draw from an appliance. However, as previously stated, they can't detect reversed wiring, overcurrent in isolation, or short circuits without further investigation. A voltage tester is a simple and inexpensive tool that can be used to check for the presence of voltage in a circuit. It can be used to verify that a circuit is de-energized before working on it, or to check for voltage at an outlet or appliance. There are two main types: contact voltage testers and non-contact voltage testers. Contact voltage testers require you to touch the wires with the tester probes, while non-contact voltage testers can detect voltage without direct contact. Surge protectors are designed to protect electronic devices from voltage spikes. Voltage spikes can be caused by lightning strikes, power surges, or other electrical disturbances. Surge protectors work by diverting the excess voltage away from the protected devices and into the ground wire. There are two main types of surge protectors: whole house surge protectors and point-of-view surge protectors. Whole house surge protectors are installed at the main electrical panel and protect all of the devices in the house. Point-of-view surge protectors are plugged into outlets and protect only the devices plugged into them. Regular electrical maintenance is essential for ensuring the safety and reliability of your electrical system. This includes inspecting wiring for damage, checking for loose connections, and testing circuit breakers and ground fault circuit interrupters, or GFCIs. It's also important to keep electrical panels clean and free of debris. During an inspection, look for signs of damage to wiring, such as frayed insulation or exposed conductors. Check for loose connections at outlets, switches, and light fixtures. Loose connections can cause overheating and potentially lead to a fire. Test circuit breakers and GFCIs to ensure they are functioning properly. Circuit breakers should trip when overloaded, and GFCIs should trip when they detect a ground fault. Clean electrical panels regularly to remove dust and debris. Dust and debris can accumulate in electrical panels and cause overheating. Also, ensure proper grounding. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. Check that all outlets, appliances, and metal enclosures are properly grounded. Consider arc fault circuit interrupters, or SIs. SIs are designed to protect against arc faults, which are dangerous electrical faults that can cause fires. SIs detect arc faults and trip the circuit breaker, preventing a fire from starting. Understanding the National Electrical Code, or NEC, is also important. The NEC sets the standards for safe electrical installations. Familiarize yourself with the NEC requirements for wiring, grounding, and overcurrent protection. When working with electricity, always follow safety precautions. Turn off the power before working on any electrical circuit. Use insulated tools and wear appropriate safety gear. If you're not comfortable working with electricity, hire a qualified electrician. Remember, even if an ammeter shows normal current flow, it doesn't guarantee that the wiring is correct or that there are no potential hazards. It's just one tool in the electrician's toolbox. A comprehensive approach involves visual inspection, voltage testing, and adherence to safety codes and best practices. Let's consider some specific examples to further illustrate these points. Imagine an electrician wiring a new outlet in a kitchen. If they accidentally swap the hot and neutral wires at the outlet, an appliance plugged into that outlet might not function correctly, or its metal casing could become energized, posing a shock hazard. Using a voltage tester after wiring the outlet can quickly identify this issue. Now, suppose a homeowner plugs a microwave, coffee maker, and toaster into the same kitchen circuit. If the combined current draw exceeds the circuit's rating, the circuit breaker should trip to prevent overheating. However, if the breaker is faulty or too large for the wiring could overheat and potentially start a fire. An ammeter could show a high current draw, but it wouldn't necessarily indicate the underlying problem with the breaker or the circuit's capacity. Consider a situation where a nail is driven through a wall and pierces an electrical wire. This could create a short circuit, causing a large amount of current to flow. The circuit breaker should trip immediately, but if it doesn't, the wiring could quickly overheat and start a fire. An ammeter might show a very high current reading, but it wouldn't pinpoint the location of the short circuit. Surge protectors are particularly important for sensitive electronic devices like computers, televisions, and home theater equipment. These devices are more susceptible to damage from voltage spikes. A whole house surge protector can protect all the devices in your home, while point-of-view surge protectors can provide additional protection for individual devices. Ground fault circuit interrupters, or GFCIs, are designed to protect against electrical shock in well locations, such as bathrooms, kitchens, and outdoor areas. GFCIs detect ground faults and trip the circuit breaker, cutting off the power before a person can be injured. SIs, or arc fault circuit interrupters, are designed to protect against arc faults, which are dangerous electrical faults that can cause fires. Arc faults can occur when there is a loose connection, damaged wiring, or a faulty appliance. SIs detect arc faults and trip the circuit breaker, preventing a fire from starting. Staying informed about electrical safety is crucial. Familiarize yourself with basic electrical concepts, safety precautions, and the local electrical codes. Attend workshops or seminars on electrical safety to learn more about how to prevent electrical hazards. If you have any doubts about your ability to perform an electrical task safely, hire a qualified electrician. Remember, electricity is powerful and can be dangerous if not handled properly. A qualified electrician has the knowledge, skills, and experience to perform electrical work safely and correctly. In conclusion, while using an ammeter for testing circuits can be a useful step, it's not a substitute for thorough electrical troubleshooting and proper installation techniques. The best approach is to engage a qualified electrician who can guarantee the safety and integrity of your electrical system, thereby avoiding costly appliance damage.